to persuade the National Fire Protection Association, or NFPA, to develop more specific standards for servo motor systems, there are several key steps. Firstly, it is critical to gather comprehensive evidence and data. This involves collecting detailed information on the usage, benefits, and any safety issues that are specifically related to servo motor systems. Focus on showcasing successful implementations. Highlight instances where robust safety features have been effectively used in factories and robotics. It is also essential to thoroughly document the limitations of the existing electrical codes when applied to the unique characteristics of servo motors. Secondly, form a collaborative group. This means reaching out to both foreign and domestic manufacturers of servo motor systems to create a working group. Engage with a wide range of industry experts, including engineers and users, to build a consensus on the need for these specific standards. Thirdly, you must submit a well-written proposal to the NFPA. The proposal should clearly outline the reasons for the new standards and cite the evidence gathered in the first step. Clearly define the scope, objectives, and technical specifications of the proposed standards. Also, get support from the collaborative group that you formed in Step 2. Fourthly, engage directly with the National Electrical Code, or NEC, committee. Schedule a meeting with the NFPA technical committee that is responsible for the NEC. During this meeting, present the proposal and supporting evidence to the committee members. Be prepared to thoroughly answer any questions and address any concerns that they may have. Fifthly, it is important to build broad support. Contact other relevant organizations such as industry associations and labor unions to get their support for the proposed standards. Attend industry events and conferences to raise awareness and engage with potential stakeholders who could be affected by these changes. Sixthly, seek official approval. The NFPA Technical Committee will review your proposal and make a recommendation to the NFPA Code-Making Panel. The Code-Making Panel will then vote on the proposal. If it is approved, the new standards will be incorporated into the next edition of the NEC. There are additional considerations to keep in mind throughout this process. Consider partnering with a recognized testing laboratory to demonstrate the safety and performance of servo motor systems. This can add credibility to your proposal. Be prepared to provide ongoing input and actively participate in the development process of the new standards. This ensures that your voice is heard and your concerns are addressed. Engage regularly with both manufacturers and users to ensure that the standards remain up to date with the latest industry advancements. This will keep the standards relevant and effective over time. Some specifics to consider regarding the differences between servo motor systems and traditional motor systems include variations in motor sizes and voltages. Servo motor systems often use motor sizes and voltages that differ significantly from the standard sizes used for induction and synchronous motors. Existing codes may not adequately address these variations. Servo motors are frequently mounted on moving parts. This requires special consideration for cable selection. Thicker cable, even if properly rated for continuous flexing and twisting, may fail sooner than thinner cable in these applications. The existing codes may not fully account for this specific need. Inrush current is often limited in modern servo motor designs. This is a significant difference from traditional motors. Newer designs often incorporate features that limit inrush current. This can reduce stress on the electrical system. Existing codes may not fully recognize these advancements. The integration of firmware and software-controlled limit and stop features is another important aspect. Many servo motor systems incorporate sophisticated firmware and software-controlled limit and stop features. There is increasing interest in using these features in lieu of additional hardware safety measures. Several manufacturers are working on getting their features listed for this purpose. These built-in functionalities can often provide faster and safer responses than traditional hardware-based safety systems. The existing codes need to be updated to recognize and allow for these advancements. To effectively make the case for new standards, it is important to gather data on the performance and reliability of these software-controlled safety features. This data can demonstrate their effectiveness and justify their use in place of traditional hardware. The proposal to the NFPA should also address the specific requirements for cable selection in servomotor systems. This should include guidance on selecting cables that are rated for continuous flexing and twisting, and that are appropriate for the specific application. The proposal should also address the issue of inertia current. It should recognize that many modern servomotor systems incorporate features that limit inertia current, and it should provide guidance on how to account for this in the design of electrical systems. The proposal should also address the integration of firmware and software-controlled limit and stop features. It should provide guidance on how to evaluate and approve these features for use in safety-critical applications. Furthermore, the proposal should consider the potential for using these features in lieu of additional hardware safety measures. The proposal should also address the need for ongoing maintenance and testing of servomotor systems. This should include guidance on how to inspect and test the system to ensure that it is operating safely and reliably. The proposal should also address the need for training of personnel who are responsible for operating and maintaining servomotor systems. This training should cover the specific safety features of the system, and it should provide guidance on how to respond to potential hazards. To further strengthen the proposal, it is helpful to include case studies of successful implementations of servomotor systems in factories and robotics. These case studies can demonstrate the benefits of the technology, and they can help to address any concerns about safety or reliability. It is also helpful to include letters of support from industry experts, engineers, and users. These letters can provide additional credibility to the proposal, and they can help to build consensus on the need for new standards. When presenting the proposal to the NFPA Technical Committee, it is important to be prepared to answer any questions and address any concerns that the committee members may have. It is also important to be respectful of the committee's time and expertise. The goal is to work collaboratively with the committee to develop standards that are both safe and effective. After the proposal has been submitted to the NFPA, it is important to continue to engage with the organization and to track the progress of the proposal. This will help to ensure that the proposal is given due consideration and that it is not overlooked. It is also important to be prepared to make revisions to the proposal based on feedback from the NFPA. The goal is to develop standards that are acceptable to all stakeholders. By following these steps, it is possible to persuade the NFPA to develop more specific standards for servomotor systems. This will help to ensure that these systems are used safely and effectively in a wide range of applications. It is important to emphasize the unique aspects of servomotor systems that differentiate them from traditional motor systems. These include the precise control capabilities, the use of feedback mechanisms, and the integration of advanced safety features. Highlight how these features can enhance safety and improve performance. The proposal should also address the potential for using servomotor systems in new and innovative applications. These include robotics, automation, and other advanced manufacturing processes. By demonstrating the potential benefits of the technology, it is possible to build support for new standards that will enable its wider adoption. In addition to addressing the technical aspects of servomotor systems, it is also important to consider the economic implications of new standards. New standards can help to reduce the cost of ownership of servomotor systems by promoting standardization and improving reliability. This can make the technology more accessible to a wider range of users. It is also important to consider the environmental implications of new standards. Servomotor systems can be more energy efficient than traditional motor systems. New standards can help to promote the use of these energy efficient technologies and can help to reduce the overall environmental impact of manufacturing processes. When developing new standards for servomotor systems, it is important to consider the needs of all stakeholders. This includes manufacturers, users, and regulatory agencies. The goal is to develop standards that are both safe and effective, and that are also practical and cost-effective. It is also important to consider the international implications of new standards. Servomotor systems are used globally. New standards should be consistent with international standards and should promote the global adoption of safe and effective technologies. In summary, persuading the NFPA to develop more specific standards for servo motor systems requires a comprehensive and collaborative approach. This includes gathering evidence, forming a collaborative group, submitting a well-written proposal, engaging with the NEC committee, building support, and seeking approval. It also requires ongoing engagement with the NFPA and a willingness to make revisions to the proposal based on feedback. By following these steps, it is possible to ensure that servo motor systems are used safely and effectively in a wide range of applications. Remember to emphasize the unique aspects of servo motor systems, address the potential for new and innovative applications, consider the economic and environmental implications of new standards, and consider the needs of all stakeholders. Also, remember to align with international standards. The end goal is to create a safer and more efficient industrial environment.